Have you ever wondered how pitchers in the major leagues can make their pitches change speed and move in the air? Well, that is what I wanted to research for my capstone project. To understand why the ball has that curved trajectory, we need to first understand how the pitchers grip the ball. The first pitch we are going to be looking at is the most commonly thrown pitch in the MLB. That pitch is called the four-seam fastball. This pitch is the fastest and moves in a straight line. To throw this pitch, you grip the ball so the seams are running perpendicular to your fingers. Here's a clip to show you what it looks like. The second pitch is called the two-seam fastball, and you grip it by having your fingers run parallel with the stitches. This pitch is slightly slower than the four-seam fastball, but the ball moves in a downwards motion, causing the batter to swing over the ball. And this is what it looks like. The slider is a pitch that, when thrown by a right-handed pitcher, will move away from a right-handed batter or into a left-handed batter, and is gripped by having your fingers tilted and pushed together. This is what that pitch looks like. Next is the cut fastball, but is also known as a cutter. A cutter is as fast as a two-seam fastball, and it moves like a slider. A cutter is gripped like this. A split-finger fastball is very similar to a two-seam fastball, but it does not move as fast, and it has a sharper downwards motion. It is gripped like this. And this is what the pitch looks like. Next is the curveball. The curveball moves from the batter's shoulders to the batter's knees when thrown correctly. You grip the ball similarly to the slider, and here is what it looks like. This is what Clayton Kershaw's 12-6 curveball looks like. This pitch is called the curveball or 12-6 curveball because it describes the ball moving from 12 on a clock to 6 on a clock while in the air. Now that we have looked at the different kinds of pitches, let's look at the physics that cause the ball to move. The scientific principle that explains the reasons as to why a pitch moves through the air is called the Magnus effect. The Magnus effect was named after German physicist H.G. Magnus. He discovered the Magnus force while studying the path of a cannonball. The Magnus effect affects any spinning cylinder or spherical solid. The Magnus effect changes the path of a baseball by flying through the air with spin. The spin causes the air around the ball to move. The air around the front of the ball is moved with the spin, and the air on the back of the ball gets diffracted. This is what causes the ball to move. The force that causes the ball to move is called the Magnus force. The velocity of the baseball can increase the power of the Magnus force because when the velocity increases, it causes the air resistance to increase. This information can be used in any sport because of the Magnus effect. It can be used in soccer, as shown here, in ping pong, as shown here, or with a basketball, as shown here.